Last time we talked, I was having one heck of a time trying to tap holes on this machine. I tried everything to fix it. I went through all of the parameters scientifically and I just kept breaking tap after tap. Nothing I did seemed to make a difference. So I'm changing assumptions now. Before I assumed it was something wrong with the tool or the parameters around the tool. Now I'm going to assume it's something wrong with my machine. What I'm checking to see now is if the spindle is in line with the Z-axis. Because if the tap is coming in at an angle like this, it's just gonna break when it hits the material. I don't really have a great way of testing this, but this is what I've come up with. I have a precision ground dowel in the machine here with a dial indicator on it. Now, I know that this dowel is not perfectly straight, but that's okay. It doesn't have to be to check for a misalignment. What we can do is move this straight down on the Z, check the dial to see how much it moved, and then rotate it 180 degrees and repeat the same process. If the dowel was perfectly straight and the spindle was perfectly straight, that needle wouldn't move. If we take two measurements, rotated 180 degrees apart, and we find that they average to 0, then we'll know that the spindle is in line in this orientation. If we take two measurements and they do not average to 0, then we will know there's a misalignment between the spindle and the Z-axis. Spoilers, I've already done it in this orientation and it averages to 0. So now we need to try it 90 degrees off to see if that makes a difference. I'm seeing basically no taper. Let's try it 90 degrees apart. Okay, I'm seeing some taper on that side. Let me make sure I'm not crazy. We'll go back around to the other side. I'm seeing no taper on the side again. Let's try turning this 90 degrees, just to confirm. We seem to have a little bit of taper in this direction. I have crunched the numbers and have decided the spindle is leaning this way by 4/10 per inch. I don't know what that works out to be degrees-wise. It's gonna be very small, but I think it might be enough to start wrecking taps. I'm not super sure exactly on how to fix this right now, but I'm hoping, fingers crossed, that I can do it by just playing with how tight these bolts are. I think if I tighten down one side more, in fact, having unequal torques may even be the cause of this issue. So by tightening down one side more, it may pull that spindle back into alignment. Before I start taking things apart, I'm gonna do an encoder test, which you run just through the MDI line, just to see what happens. The encoder test worked, it's happy. As far as I can tell, my spindle is leaning this way. I'm hoping by tightening the bolts on this side, we can kind of pull it back this way. I don't know if that will work, but I really, really hope it does. Let's hope it was that easy. I'm gonna do the same measurements again to see if we got any changes. The numbers are in. So before that change, we were tapered by 4/10 this way. Now it's 1/10 1/4 this way. So we overdid it. So now I'm gonna tighten the bolts on the other side just a little bit, and hopefully we can dial it in to be 0 or close to 0. I was able to get that tram better. It's not perfect, but it's better. On my last little adjustment, I measured it once and it measured as basically 0 angle. I did it again and it measured at about 2/10. So my accuracy is about plus or minus 1/10. I don't think I'm gonna be able to get any better than that. I don't think I can measure more accurately than that. I'm calling it good enough for now. Next thing I'm gonna check is I'm gonna take this little handheld tachometer and just see if the numbers that give me remotely matches up with these numbers. If it's like 10% off, like that might be an indicator something's weird. Or if the RPM is surging, that would also be an indicator something's weird. I don't think that thing's gonna be quite accurate enough to give me really scientific results, because even a 1% error could break these taps, but it'll just help me see if there's anything really weird going on. I have the spindle test results, and they're kind of interesting. At 250 RPM, the minimum RPM, the air starts out at about 0.5% too slow. As you ramp it up, it slowly ramps up to about 4.5% too slow. So at 10,000 RPM, it is running around 9,600 RPM. I don't know if that's what's gonna do it here, because theoretically the encoder should move the machine in time with the actual RPM, not the commanded RPM. But I don't know, I'm just grasping at straws at this point. I'm gonna try running the program one more time. Maybe some of the tweaks I've done today will fix it. I'm gonna run it at 350 RPM, which was the most accurate RPM when I was doing my tachometer tests. And I'm also gonna try recording it in slow motion on my phone, just to see if I see anything. I probably won't. I don't think my slow motion's good enough, but worth a try. It, of course, still snapped right off. Yesterday was not a productive day for me. All I did was manage to rule out all of the things that weren't contributing to the breakage of the tool. So I still don't know what my problem is. What I do know is I didn't do basically everything that I was supposed to do yesterday. So I need to get caught up on that stuff now. Scott should be here in about 20 minutes. He worked from home the last 2 days, but he should be here today. We are just shipping 2 things today. We have the copper orange slice and then a special edition carabiner. This is the spring sunrise color. There's only a couple of these left. So this little dot right here is our tapping head. When it gets to here, hopefully we can make a functioning carabiner. Scott and I just had a little bit of a meeting and I figured out my goals for today, whether or not those parts get here and work. Scott, what are you working on?
I'm getting my keyboard to work.
What happened to your keyboard?
What happened to my keyboard? It shows a rainbow all the time, and I don't want it to show a rainbow.
No. It's not rainbow.
I know, I unplugged it.
Oh, okay.
I can plug it in for demonstration purposes.
Your plant is also a rainbow?
My plant will always be magenta.
Yeah. So what you working on, Scott?
For real?
Yes.
I'm going to edit 2 of our videos and then make a social media plan.
Cool.
For the Kickstarter.
And I am going to start by cleaning up the mess I made yesterday. Hey, Scott. I have 4... Okay, never mind. We can't stage things because then we'll laugh. So I have 4 or 5 sets of scales. Should we powder coat those or leave them tumbled? Should I do a bunch of colors? Should I just leave them all tumbled?
Did we decide this? We went back and forth so many times.
I think we have to do colors.
So everything colored, middle colored, outside colored?
Yes.
Then yeah, I mean, as many colors as we can get.
Okay. We can always recoat them if we need to. What colors do you want first?
Orange.
Orange. It's been a couple hours now, and I have been watching the truck on the map, and it has not gone any closer. Actually, it got closer, and then it got farther away again. See, the truck is all the way down there. It needs to get here. It's been to like here, but then it went away again. Now, I'm not going to be able to even try to get the tapping to work until that truck gets here. So I'm still waiting. In the meantime, I've been working on the Kickstarter campaign. Scott, what have you been working on?
Oh. We're doing this now. I'm just gonna hold it. I have just been working on editing one very long vlog all day. The last video I think was about 7 minutes, and this one I have worked through like 30% of the video, and we're at 15 minutes. So
Yeah. A lot happened in that one.
Yes, it's not going to be a short one.
Hey everybody, a package finally showed up yesterday. Now it showed up too late yesterday to be of any use yesterday, but today we can hopefully conquer this tapping issue. The most important thing that showed up was this. This is a floating tap holder. Basically, the idea behind this is that if there is any desync between how fast the Z-axis is moving and how fast the spindle is turning, the tap will break. If the spindle is turning too fast, the tap will just tear itself in half. If the spindle is spinning too slow, it'll just kind of crunch the tap. This tap holder has some springiness in it. It's kind of hard to see. It's fairly stiff, but it stretches and compresses, which means that it can take up any slop that is left over in the kinematics on this machine. If this doesn't work, I'm out of ideas. Let's give it a try. The machine is going through a warm-up cycle right now. In other news, I missed trash day again. All right, it's ready. Is it gonna work this time? Let's find out. And go. It's drilling. Oh, come on, the drill broke. Did it break in the first hole? That's all I care about. The drill broke in the first hole. We gotta do this again. And here we go again. I didn't hear the drill break, but you don't hear these drills break. They're too small. They just disappear. The drill is still there, that's a good thing. Let's go to the tap. Okay. Let's get a little bit of oil in here. I'm gonna confidently oil all the holes and the tap. All right, here we go. It worked! It did it! That took so long. It did all 4 holes in a row. That was the secret. It was the tapping head. Gosh, some sort of kinematic issue with the machine just didn't let that work. I don't know why it's worked in the past and it hasn't worked now. I'm gonna blame the spindle replacement. I am so happy that that is finally working. We'll see if it's reliable, but at very least we got 4 holes in a row. Anyway, if you want to buy something we make, designedeverything.com. I'll see you in the next video. It has gotten very cold outside, but that isn't relevant for this video.